Welcome friends. So today we will discuss one question based on acid base concept. The question is the order of acidic strength of the conjugate acids is four options are given and four conjugate acids are given. So we can conclude the answer by reviewing the relative stability of the conjugate acids. More stable the compound conjugate acids means that is less acidic. So first consider the first one. If we take pyrrole, let's take pyrrole, that is an aromatic compound, right? So pyrrole is an aromatic compound. When it's combined with an acid, it forms this conjugate acid. Okay, the conjugate acid of pyrrole. The conjugate acid of pyrrole. Now consider this one. This compound is aromatic and this compound is anti-aromatic. If you can see, there is 4 pi electron system, that this is an anti-aromatic system. That means this equilibrium will shift towards the left. That means this compound is less stable. That means that will readily lose one of its hydrogen ion and it will form H+ ion. That means that will be more acidic. So conjugate base is less stable. That means this one is more acidic. Now consider these two, Q and R. That's case of imidazole. So let's first take the case of imidazole. If we take imidazole and okay, so this is imidazole. There is one lone pair is present here. This is also it is an aromatic compound, but its conjugate acid that is given here, this is also aromatic in nature, because this lone pair is not participating in the aromatic conjugation. Okay, so this is also aromatic in nature. Now if you consider these two, okay, so if we draw the resonating structure of this compound, so let's say this lone pair is moving over here. This is on the nitrogen atom, or it is circulating over the. So this resonating structure you can write this nitrogen over in H plus double bond, here is a negative charge, that is also okay, and etc. In this case also you can write resonating structures based on the using the lone pair of nitrogen that is conjugating with the ring, that is in the case of. So here if you can see that positive charge is delocalized between two nitrogen atoms. Let's say there is hydrogen and now positive charge over here and another few more aromatic structure you can draw. Now check this one. So in this case the positive charge is delocalized between two nitrogen atoms. In structure you can see that the charge separation is happening. That means these resonating structures are non-equivalent resonating structures, where these resonating structures are equivalent resonating structures. This compound, this conjugate acid is much more stable. It is very much stable. Okay, so that means it will not release H+ that easily. That means acidic strength, if we consider that one in this case, is less. the third one, the dihydroimidazole, actually 3,4-dihydroimidazole. This case, if we consider, okay, here is the lone pair. Okay, so it will accept one proton and form the conjugate acid. Now here is the conjugate acid. Now compare these two, imidazole and 3,4-dihydroimidazole. Imidazole and 3,4-dihydroimidazole, this one is more basic. That means the conjugate acid is more stable. This is more stable, okay, compared to less stable. So how we can say, so this is more basic and this is less basic. The reason behind this is, here you can see that this carbon is sp3 hybridized and is pushing electron through plus I effect to the nitrogen atom. The density of the electron on nitrogen atom increases in this case. But here you can see this is sp2 and this is also sp2 carbon. So two sp2 carbons are attached with the nitrogen atom. This sp2 carbon is electron withdrawing. That means that will decrease the electron density on the nitrogen atom. That means imidazole is less basic compared to that of 3,4-dihydroimidazole. So in this case, the dihydroimidazole forms more stable conjugate acid, right? That means this conjugate acid is more stable compared to that one. And so if we think the reverse case and the acidity order, so this will be less acidic compared to this one. Okay, now we have the fourth case. That case is the conjugate acid of pyridine. Okay, so conjugate acid of pyridine, this is also aromatic compound. It will accept one proton and it will form the conjugate acid. So this conjugate acid, you can see that the positive charge is localized only one nitrogen atom, where in case of imidazole, the positive charge, the conjugate acid of imidazole, its conjugate charge is delocalized between two nitrogen atoms. That means that will be less stable than this is Q, right? Less stable than Q. Okay, so this one is our P, this one is Q, PQ, this one is R, and this is S. So S is less stable than Q. We can say there's the nitrogen positive charge on nitrogen is localized here, positive charge is delocalized. Okay, so this is less stable, that means more acidic. More acidic. So now if we look for the options given here, so we have seen that this one is anti-aromatic, so least stable, that means it is more acidic. So P is more acidic. We have two options having P is more acidic, right? Then we have S, that means this compound where nitrogen positive charge is localized on nitrogen atom, and two cases we have where positive charge is delocalized between nitrogen atoms. So Q and S, R and Q. So if we compare these two, the less stable is Q, that means Q is more acidic than R. So the correct answer is A. So thank you very much guys for watching this video. Please please subscribe to our YouTube channel and log on to our website www.medhacare.com. You can write email to us at info@medhacare.com, or you can call anytime. So please feel free to ask questions. We will be very much happy to discuss more and more questions for upcoming NEET examination. Thank you very much, guys.